This conference will now be recorded.
So again, I'd like to welcome everybody today, and thank you for attending. We're here today to talk about PFAS and the new changes that have occurred relative to the practice of managing solid waste facilities and other types of public infrastructure that have been impacted by this newly emerging contaminant. Before we begin, I'm going to tell you very briefly about CEC. CEC is Civil and Environmental Consultants. We are consultants working in civil engineering and the environmental sciences. We're based out of Pittsburgh, Pennsylvania. We've got over 1,000 employees. One of the defining characteristics is we are employee owned, and more than half of our employees are shareholders. We feel that results in really superior client service. We've got offices not quite around the country, but in a swath from Massachusetts to Arizona. We have experts in a variety of different disciplines, and we're always interested if folks have questions. We're always ready to answer and pick up the phone and try to give some good advice. We work in a variety of different market sectors. Most relevant today, I think, are public sector and solid waste. My understanding is that folks on the front line operate in those areas. So for our agenda today, I think we'll probably be anywhere from 40 minutes to an hour. We're going to talk about PFAS. I'm going to give you a little bit of background. We're going to talk about chemistry briefly, because I don't think that anybody here needs to become a chemist in order to deal with the issues that they may face regarding PFAS. We'll talk about the regulatory context, some things you might need to know if you are starting to do sampling or monitoring for PFAS, or if you've got consultants out there sampling and monitoring. We'll talk about some analytical issues relative to analyzing for PFAS, leachate management if you're working on solid waste facilities, treatment options, legal issues, PR issues, and lastly, due diligence implications, because as we start to look for more facilities for solid waste infrastructure or buying and selling properties, it's becoming very critical. So just as a bit of background here, you've got a typical model of a PFAS compound here. When we talk about PFAS, these are per polyfluoroalkyl alkyl substances. They are essentially, you've got a carbon chain, either straight or sometimes branched, and you've got either another carbon, they're fluorinated, and you've either got another carbon group or a sulfur-based compound at what you'd call maybe the head of the molecule. So when we talk about PFAS in general, we're including what you'll hear referred to as PFOA, PFAS, as well as Gen X and some of the newer compounds. We're talking about a group of thousands of compounds when we use this generalization. And these compounds have been manufactured and in use since the 1940s. Why are we talking about PFAS so much lately? Why are we talking about it here today? Well, it's found in a lot of products, so it's out there. It's out there in our environment and in our daily lives. The EPA has set a drinking water advisory of 70 parts per trillion. That's a very, very low number, and because of that, you're going to detect it at a relatively high frequency. Another reason why we focus on it is states are taking the lead on regulations. There's a lot of states, some of which are looking at even lower standards than EPA has. They're looking at enforcement in different ways, and they're looking at what we call site discovery in different ways. Some states are making the regulated facilities look for these compounds. Other states aren't. So you really need to know the local rules of the game, so to speak, and you need to be keeping an eye on them because they are changing quickly. Legal concerns. There's certainly an uncertainty. There's a lot of uncertainty with regard to what will happen with PFAS. Some folks will say, you know, boy, the risk data is really not there, and these standards will go in a different direction later. Others folks might say they might get even more stringent. More and more states may start to regulate PFAS at lower concentrations. And really what makes it a problematic contaminant is, you know, it's mobile in the environment, at least some of the PFAS compounds are. They're persistent, they're bioaccumulative, so they build up in organisms. They're difficult, of course, costly to remove and destroy, and they're believed to be relatively toxic at low concentrations. So that's sort of the perfect storm when it comes to new contaminants. That's going to make them challenging and somewhat costly to deal with. So as I just mentioned, certain PFAS compounds are mobile, persistent, and bioaccumulative, and don't degrade in the environment. The notable ones that you hear about a lot are PFOA and PFAS. And what you also find is that there are more complex PFAS compounds that degrade to PFOA and PFAS. So that makes it a little bit tricky when you start to look at analysis and quantifying what you have in the environment. You may or may not be quantifying all the compounds that may ultimately degrade into those compounds that are most regulated. PFOA and PFAS, if you look across the states, are going to be the two most commonly regulated of the PFAS compounds. So this chart gives you a little bit of history of the various PFAS compounds, starting with PTFE, you know, essentially Teflon, invented in the 30s, going into use in the 40s, and then PFAS and PFOA going into use in the 50s and 60s. And then today, you know, we're using essentially shorter chain compounds, which we'll get to later. You know, the toxicity has not really been all that well evaluated for those compounds either. I'd say the belief, or at least hope, is that those compounds will be less problematic. So where are PFAS? And I think you've kind of heard the answer is everywhere. They're in our foods. It comes from packaging. You know, the burger you get from the fast food restaurant, the bag you cook your microwave popcorn in, the pizza box that your pizza comes in, all, like in many cases, contain PFAS. They're in household products, especially fabrics, you know, in your rugs, in your upholstery, in your clothing. So a lot of it around you. It's in firefighting foams that are used to fight certain types of fires. And it's in the workplace. I failed to mention on the prior slide, a little bit back here, it's worth going back for a second and talking about the US really reduced a lot of the use of PFAS compounds in the 2000s. They've been replaced with other PFAS compounds, and PFOA and PFOS is also produced overseas. So it's still in our environment, although hopefully less frequently. So production facilities that are making fabrics that are coated, make chrome plating facilities, all may use PFAS compounds. It's in drinking water, and usually it's in drinking water associated with some sort of a localized source. It could be a manufacturer one of those manufacturers that we talked about. Generally there you'll find relatively higher concentrations of PFAS compounds. It can also be in drinking water near landfills, wastewater treatment areas, areas where wastewater sludges are being applied. Those concentrations tend to be not as high, but still in many cases well above the applicable standard, which is often 70 parts per trillion. Firefighter training facilities are another area where you get some very high concentrations if they were training with PFAS containing foams. This map's from 2016. It's probably already a bit dated. It shows areas where PFAS has been detected in drinking water. Don't think that because it's painted blue that all the drinking water in that area has PFAS. It's sort of a global average look at things, but you can see a lot of the populated areas of our country do have water supplies where PFAS has been detected. And PFAS is in living organisms, fish, animals, and people. We all probably have PFAS in our blood. There have been studies to try to find populations that don't have PFAS in their blood, and it's pretty difficult. Most of us in America and probably the world have some concentration of PFAS in our blood. So that was all pretty sobering news. You'll see this slide in almost every PFAS presentation, I think, because it's at least a little bit of good news. I mentioned that in the United States, PFOA and PFAS were sort of phased out. And you'll see these are blood concentrations. You'll see that, a definite cause and effect there. Blood concentrations of those two compounds in America are decreasing, and we think that's a good thing. So this is just a listing of some of the things you're going to find PFAS in. It's in a lot of stuff. We've mentioned most of these things already. Cleaning products, personal care products, shampoo, dental floss, candy wrappers, really in a lot of different things that we use day to day. I say, it used to be when you were a little kid and you spilled some juice on your shirt or something, it was a big deal, right? Today, mostly it just beads up and rolls off. A lot of that has to do with PFAS. There's a few other things that are used also, but certainly those types of waterproof properties that you're seeing are related to PFAS. So this all feels like a new problem, and certainly it's been gaining more and more publicity recently. You've got a documentary on Netflix about it. You've got a major motion picture about it. But we've known for a little while, at least. So in 2001, 3M commissioned a study of PFAS in food, and they found PFOA and PFAS in beef, pork, chicken, milk, green beans, eggs, bread, in 6 cities in the Southeast. And 2019, FDA did a study, and they found it in a wide variety of foods. The one that got a lot of media attention was the fairly high concentrations, 17,640 parts per trillion in chocolate cake. I think it got attention because of the concentration as well as the fact of, who wants to hear chocolate cake is going to hurt you. A little note there is that if you applied New York's proposed drinking water guidelines of 10 parts per trillion, that chocolate cake could contaminate thousands of gallons of water. So that kind of gives you some sense of how ubiquitous these materials are, as well as how low those proposed standards are. The chemistry, suffice it to say, is pretty darn complicated. there are thousands of compounds. You know, the general consensus, I think, is around somewhere around 3,000 compounds. They don't all behave exactly alike. The naming conventions have been somewhat inconsistent, and I think they're pushing towards standardizing some of those naming conventions. But the names are long, they sound similar, kind of exotic sounding names. You can see some of them over there on the left. And that all leads to, at times, a bit of confusion. When you're looking at analytical data, I'll find I'm often looking at the CAS number, which is unique, as opposed to looking at the compound names, because they do all kind of blend together. So regulatory climate, geography really does matter when it comes to PFAS. States are taking the lead, setting standards. The standards vary dramatically. How those standards are applied is relatively inconsistent. States are looking at different numbers and combinations of PFAS compounds. EPA did establish a health advisory level of 70 parts per trillion. That's probably the number you're going to see the most. I'm not sure where everyone is today, but you know, ultimately the Northeast really has pushed, and maybe California, I guess, also pushed to have lower and lower standards. 70 is where, you know, I think a lot of what's going to apply, at least in the short term, in a lot of parts of the country. And, you know, those standards were based on some animal studies, as well as some epidemiological studies. But my understanding in talking with risk assessors is that, you know, those studies are far from complete. There's a lot of uncertainty with regard to risk. And because of that uncertainty, you'll see something like this. Here's the mouse study that's the basis for the 70 parts per trillion. The lowest effects level for mice was 1 milligram per kilogram per day. It was adjusted downward to 0.005 to account for the fact that it sticks around a lot longer in humans. You can see that's, you know, several orders of magnitude lower. And then a safety factor of 300 was applied. So, you know, you're all of a sudden 1, 2, 3, I don't know, is that 5 orders of magnitude lower, 6 orders of magnitude lower? You're coming up with very low standards. My understanding in talking with a lot of folks in the risk assessment community is that if those same standards were applied to some of the other more common compounds that we've been regulating for many years, the numbers would be much lower for those compounds also. So why all the conservatism with regard to standards and compounds? It's because there are effects believed to be potential effects with regard to exposure to PFAS. Those effects include, you know, everything from birth defects to types of cancer to increased cholesterol. That's sort of why we are where we are. This gives you a picture of how states are regulating PFAS, as we discussed. If you look at the Northeast, orange means that the state has adopted a standard less than the 70 parts per trillion. I'll tell you, New Hampshire and Massachusetts certainly are headed towards being in that orange category. You maybe even, depending upon how you view it, could color them that way now. And I'm sure there's some other states. I think the trend is certainly being established that many states will go lower than 70 parts per trillion, as low as potentially 10 or 20 parts per trillion. This summarizes some of the different states and how they are viewing and regulating PFAS in drinking water. You'll see, for example, you know, the EPA number, like we talked about, is the sum of the PFOS and PFOA. That's how they get to 70, versus, say, Massachusetts, which is summing up 6 different compounds and having a standard of 20. So at these levels, you know, 20 is significantly lower than 70 when you're dealing with these trace levels. You're also adding, you know, 6 numbers instead of adding 2. So these are really becoming, they're going from being quite conservative standards to really even more so. And with that, you'll find it, the lower we look, the more we'll find it. So if you are going out there to do groundwater sampling or soil sampling, or you're having consultants do that for you at facilities, be it a landfill or maybe around a place where you think you've had a release, fire training academy, sludge composting facility, something like that. What do you need to do? First thing you need to do is do your homework. Find out if your state has a guidance on sampling. Many states do. If they don't, look to a guidance such as Michigan is a very comprehensive guidance. ITRC is an organization that has some good guidance. Your labs might have some instructions for you. And I'd really suggest, even if your state has standards or guidance for sampling, that you look at a couple of sources. Keep things simple. The more equipment that you have, the more you need to worry about PFAS in that equipment. If you're going to use a, you know, stainless steel submersible pump to purge your well, you need to worry about all the seals in that pump, all the parts in there. Versus if you're going to use a baler or tubing with a check valve, is much fewer items you need to worry about potentially containing PFAS. Think about what types of things are prohibited with regard to equipment and clothing. Refrain from the use of any personal care products on the days you're doing those sampling. With that, I think, you know, one important thing from a safety standpoint is that you consider alternatives. There's bug sprays and sunscreens that you're not allowed to use. You want to encourage your staff to use ones that are on the safe list with regard to not containing PFAS, because, you know, we don't need people to get burnt or Lyme disease or anything like that because they're going out to PFAS sampling. Lastly, use duplicates and field blanks. You know, that's something that in some parts of the country we in the environmental industry have done less of, as folks, depending on what programs you're working on, a lot of programs don't require them anymore. They are really essential when it comes to sampling for PFAS. You need to know that you're not getting false positives based upon the equipment you're using or the personal care products on your employees or anything like that. And you need duplicates because you want to make sure that these labs that you use are giving you results that are reproducible. So what can be sources of contamination when you're sampling for PFAS? Teflon and equipment and containers. Field books, write in the rain field books are no-no. Post-it notes, can't use those. Your field forms, again, if you're using write in the rain paper. Your lunch, if you're going to, you know, your fast food restaurant and bringing back getting nice PFAS coated paper. And personal care products, as we mentioned. So I know a lot of folks that maybe are managing solid waste type facilities maybe they're not doing the sampling themselves, but they know that maybe they're going to be asked to add it to monitoring programs, and you want to know what it's going to cost. So certainly, if PFAS becomes required in your state for a monitoring program, There will be additional analytical cost. That's a certainty. The analysis is not inexpensive. Multiple hundreds of dollars a sample, maybe $300–400 a sample. There could be labor cost premiums. It depends upon site conditions. There may be just small tweaks to your monitoring program. If you're, say, using tubing and check valves to purge the wells. If you've got deep groundwater that requires low flow sampling requirements, something like that, could be more costly. And I think there'll be, certainly the potential for some first round preparation costs. There's a little bit of learning curve there. Both if your consultant doesn't have experience doing it, which hopefully they will, but also just in terms of each site will have a little bit of learning curve, I think. You may have to, you may need to change it if you're using dedicated tubing, dedicated bailers, that sort of thing. You may need to change those out the first time around. So from the monitoring programs that we've been doing over the past several years, we'll share some of our observations. People have concern that you can't do the sampling without cross-contamination. PFAS is everywhere and your samples are going to get cross-contaminated. That has not proven to be the case with us. As we've done our sampling, we've found really no instances of cross-contamination. We've been very careful about how we do the sampling, but we haven't found cross-contamination to be a problem. We found the results at wells over time are very reproducible, similar to the variation that you get with any other contaminants. With long-term, say, landfill monitoring programs, we're seeing just the wells that are dirty are dirty quarter after quarter with similar results. Our field duplicates have shown good reproducibility, so we have a lot of confidence in the labs we've been using. And we do rinse safe blanks, and we've been able to show that we're not getting PFAS off of the sampling equipment. So it can certainly be done. There is, it's prudent to apply caution when you're going out there to do PFAS sampling, especially for the first time, but it's very doable. What about surface water sampling? So there's a few things you need to think about there. Yeah, what's in your waders? Are your waders coated with something, or your flotation device? So I think you are often going to want to think about whether you can work from the shore. That might be helpful. There's another phenomenon just to be aware of also with PFAS, and that's so these little red dots with the squiggle really represent the PFAS molecule. It's got a hydrophilic head and a hydrophobic tail. So the long carbon chain doesn't like water, and they'll line up like it shows in this picture here, sticking their tails out of the water and create what's been reported as an invisible sheen. So something to be aware of with surface water PFAS sampling is if you're skimming off the top of the surface, you may be getting a higher concentration that exists in the bulk of the water. So you need to ask yourself before you do surface water sampling, what's really your goal? If you're in a setting where you don't expect PFAS to exist, and you're really screening for it, well, maybe collecting off the surface is perfectly fine. If you're in a long-term monitoring program where PFAS does exist, maybe you'll be looking for something different, and you're going to want to think about reproducibility and making sure folks are sampling in the same way. We've spoke a lot about these low standards. This just gives you a little bit of a sense of it. In the environmental industry, we're very used to parts per million. Parts per million, a drop of water in 2 bathtubs of water. You go, wow, that's not a lot. Parts per billion, we're kind of used to that too. That's a drop in a swimming pool. Parts per trillion is really like a drop in a lake. It's really a very low concentration. And as you can imagine, having standards in the parts per trillion, at the parts per trillion level really result in having potentially vast areas of contamination that are over standards. How do you confidently measure, as low as 20, oops, I'm sorry, that is ppb up there. It really should have been nanograms per liter. That's a question that folks have asked a lot. You'll hear folks in the industry who are kind of just getting involved in these issues, and by industry I mean say solid waste industry or wastewater industry, and let's see, those labs can't even measure those concentrations. In fact, they have been able to measure those concentrations and do a pretty good job at it. It's taken a little while to kind of get folks on the same standards and those sorts of things, but there are a number of labs out there doing a pretty good job. The method is generally EPEA method 537, revision 1.1. You've got to talk to your lab about what compounds you're going to get. Oftentimes, you're going to get 14 compounds. That might be kind of a typical number. Remember that there are maybe 3,000 or more compounds out there, so you're only measuring a very small portion of what's out there. And some labs will give you maybe up to 25, still a very small portion. There's something that you should be aware of. You might hear people talk about the total oxidizable precursor assay or top assay. It's another analytical method available to you. This addresses the thing I mentioned earlier in the presentation, where compounds will often break down to PFOS and PFOA. This is a process by which a sample is analyzed and then oxidized and through a very aggressive oxidation, and then reanalyzed. And that can kind of help you see some of those compounds that you're not seeing in the traditional analysis by converting them to compounds that you can see. Difficult matrices. If you're dealing with solid waste facilities, you'll have leachate. While we've gotten pretty good at analyzing low concentrations of PFAS, leachate's always difficult to analyze, no matter what you're running. So you want to talk to your lab about the leachate analysis and see what how they're going to handle that. And then there's always the PFOA and PFOS replacements, Gen X and those compounds. It's something to think about, what's the purpose of your sampling, and do you want to be analyzing for those compounds? And if you do, you really need to talk to your lab about that. Leachate management. Here in the Northeast, it's been interesting over the past few months. There's essentially, you could almost call it a cycle, right? I mean, we all throw away our trash and everything else. Let me step back. So we have PFAS in wastewater, and wastewater treatment plants have been dealing with that issue. They need a place for that to go. Landfills are generating some PFAS in leachate because things we throw away have PFAS in them. Landfill leachate is often brought to POTWs, wastewater treatment plants. In this region, we've been seeing wastewater treatment plants not want to take leachate more and more frequently. Of course, those wastewater treatment plants are generating sludges, which, at least in this region, are often going into landfills. So you've got landfills not wanting to take sludge and wastewater treatment plants not wanting to take leachate, and you've got this cycle sort of between those two. Suffice it to say that from a leachate standpoint, the number of outlets to send your leachate somewhere else are getting fewer and fewer, and on-site treatment is getting to be more likely. So with regard to treating PFAS, there are technologies that work on some of the compounds or many of the compounds. Got to remember, these compounds are not all the same, so we've got to take that into consideration. Sort of your most common treatment methods that are out there for you that have been proven to have success are carbon, single-use resins, and reverse osmosis. You've got a bunch of others here, and there's a lot of folks looking into new and different ways to treat PFAS. So if you're going to look at GAC, granulated activated carbon, so that basically absorbs compounds onto the carbon surface, and then that can either be regenerated or disposed, essentially. It's generally got to be disposed of at a very high temperature to destroy the PFAS. And then we need to think about potentially air emissions, because it has been shown, you know, that facilities, more like manufacturing facilities, can have air can be a significant transport mechanism for PFAS. I suppose if you're getting adequate destruction in your furnace, that may not be an issue, but I think it may remain to be seen a little bit. It's just an example project for granular activated carbon, giving an idea of the sort of the process. Another thing to think about with carbon is that absorption characteristics vary depending upon the PFAS compound. We also need to remember that we're not just going to be treating PFAS, we're going to be treating a whole bunch of other things when we run through carbon. These two curves, so your sorbed concentration is on your y-axis, and your equilibrium concentrations on your x-axis. The thing to note is the difference on the scale here on the sorbed concentration. So you're going to essentially get to the end of the life of your carbon when your compound that has the least absorption capacity, or that gets burnt out first, I guess, just to kind of put in plain terms, reaches that limit, right? You might still be able to absorb more of one compound, but because of another compound, you've got to change out your carbon. Single-use resins, from a facility operations standpoint, I think are preferred. They tend to be pretty simple, pretty effective. They need less contact time. But then again, you also have this resin that needs to get, that's more expensive, and then needs to get disposed of on a regular basis. With any of these methods, or with GAC and ion exchange, certainly, if you're trying to treat leachate, you've got to realize that, you know, that's going to complicate things significantly. You know, while these methods have been shown to work to treat PFAS in water, treating them in leachate is a little different because of all of the other stuff that you've got in there, and that those different compounds and that chemistry can certainly consume either your resin or your carbon, or interfere with the process, which means that pre-treatment may be more and more important at these facilities. Reverse osmosis appears to work effectively. I know that there's some landfills using it to treat PFAS. Problem is, you know, you create a waste stream that's PFAS free, but you also create a concentrated waste stream, what you'd call your reject water, and you've got to do something with that material too. Possibly, you know, solidification or evaporation. Again, with evaporation, we've got to think about whether air emissions are important. So here's your kind of example. If you've got leachate going in, yep, you've got 90% of clean water coming out through reverse osmosis, but you've still got maybe 10% that's got to go somewhere else Is it possible to permit to put it back into your landfill? Maybe. So that's something to consider. It's just a chart that gives you an idea of some of the methodologies that are out there, and which ones have been shown successful for different PFAS compounds. Litigation. I won't say too much about litigation other than to say it's here, it's coming. It's something to be aware of as these compounds are more and more in the public eye, as things like property transactions are done without an awareness of the potential for these compounds to be in place, or where materials are disposed without an awareness of the fact that these compounds are in the materials. We'll certainly see more and more litigation. Public relations. So if folks have had some exposure to handling public relations with an environmental contaminant, it hasn't really changed. It's similar to all other environmental contamination issues, but in other ways it's different. PFAS is a hot topic, and people react to contaminants in different ways. People have perceptions of risk that may not be proportional to the actual risk. And what makes people perceive a high level of risk? Man-made chemicals, right? People tend to be more afraid of PCBs than they are lead, even though some would argue, lead probably has a greater environmental impact. Exotic chemical names and properties, people certainly are more sense more risk when they see those. Things that are ubiquitous, it's everywhere. It's certainly scares people. Potential carcinogens always scare people, right? Nobody really wants to hear about cancer-causing things, and the fact that it's in pretty much everybody's blood. All of these things are going to make it a really sensitive and charged issue if you happen to run into a scenario where you've got a site with PFAS. Due diligence. Ultimately, infrastructure. We still need infrastructure. We still need solid waste infrastructure. We still need wastewater infrastructure. And what we've observed is that nearly every solid waste due diligence project that we've touched in the past few years, PFAS is getting considered, right? It's becoming a way of life. A solid waste industry or company can't just say, we're not going to deal with PFAS. They already are. So what does that mean from a due diligence standpoint? The first thing is, if you're going to either buy or sell a property, you're doing some form of due diligence, talk to your consultant. PFAS is not technically a hazardous waste or hazardous substance at this time. It's heading that way. So the question is, will it be an REC, which is a recognized environmental concern? Under the standards that apply to doing due diligence, that's a defined term. PFAS may not fit that defined term, or that might be your consultant's opinion, but you want to let them know you care about it. You want to let them know that we want to consider PFAS. Next thing is consider whether there's data available, and what are the benefits of getting baseline data. It's a scary thing. If you're dealing with a property and you're looking at buying it, and it has some solid waste history or some wastewater use history, you probably want to consider whether you need baseline data. A lot of times in the past, we'd like to stick our heads in the sand and not get that data. And there might be certain circumstances where that makes sense for a particular individual or organization, but I think you've got to at least ask the question. If you already know that PFAS is present on the property, and we've had a number of instances where we've helped with due diligence, and that's been the case. You got to think about, is it attributable to the property? And if it's not attributable to the property, can that property get quote unquote blamed in the future anyway? Are they going to get dragged into lawsuits? Think about what receptors are nearby. In the solid waste industry, there are probably going to be a lot of properties, there already are a lot, but there'll be more, that have PFAS on them. The distinguishing factor is going to be, in terms of risk, what's nearby. If you have private wells or public wells down gradient from the facility that groundwater could flow to, that's going to look very different from a scenario where you don't have those. And you got to think about what state you're in. What are the rules today in that state? And you've got to kind of look in your crystal ball and try to figure out what the rules are going to be tomorrow, because that's all going to play a role in the last thing, which is ultimately estimating risk. I think it's going to be, like I said before, very hard for a company or entity in the solid waste industry to just say, you know, we're not going to deal with properties that have PFAS on them moving forward. I think they're going to need to look at properties carefully and quantify what risks exist relative to those properties. So sort of the take homes for today. PFAS, remember that it's a lot of compounds and they don't all behave the same. Remember that they're everywhere, that regulations are developing at the state level, and that they're variable and likely to change in the future. If you're going to be sampling for PFAS at a solid waste facility that you manage, it's got to be done with care. If you are doing more, if you're monitoring and you're talking with your lab, you want to be careful. You want to know what compounds you're looking for. If you're handling leachate, expect that it's going to become more difficult, especially if you're currently sending leachate to a wastewater treatment plant. It may mean you have to do some pre-treatment or treatment on site. With regard to treatment, carbon is most common. There's lots of interest in new technologies, a lot of people trying to figure out a better way to do things. Legal issues are probably going to become more common. PR issues are the same as all other contaminants, but it's a little more scary for people, and we need to be sensitive to that. And then lastly, with regard to due diligence, if you're looking at buying properties, selling properties, think about whether you need a baseline condition on that property to know what contaminants are there today, and think about how you're going to estimate risk. With that, I'm happy to take any questions that folks have.
Great, thank you so much, John. That was really interesting, and hopefully everyone has some good questions for you. I think folks can unmute yourself at the top of the GoToMeeting if you have any questions, or type in the chat box.
You said they're recognized as what concern?
Sorry, could you go again?
You said that they are recognized as concern. There was a term that he said it's recognized as some kind of concern.
So I was speaking about recognized environmental conditions, which is a term, sort of a term of art in the due diligence industry, which is if you're going to buy a property, many times folks will ask you, or you'll go ahead and get what's called a phase 1 environmental site assessment. That's sort of the standard way to evaluate properties that you're looking at buying and conduct environmental due diligence. Within that methodology, there is a term called recognized environmental conditions. Those are things that the professional is going to bring to your attention as possible concerns in the transaction. Strictly speaking, most environmental professionals would say that PFAS are not covered by those recognized environmental conditions at this time, because they're not recognized as a hazardous material. That's likely to change, and I think, you know, hopefully your consultant, you want to have a conversation with your consultant and make sure they're just not going to turn a blind eye to PFAS altogether. You want to have a discussion and ask them how they're going to handle it, if they think it's a concern on the property, if it's something they think you should evaluate or not evaluate. Just make sure you're bringing it up as a topic if you're interested in having a property transaction relative to this type of stuff.
Thank you. And this is part of NEPAS.
Well, thank you, Jonathan. This is Jacqueline Shirley down here in Albuquerque, New Mexico. Your presentation was quite eye-opening. I did not realize PFAS was in so many common products. I was under the impression it was mostly firefighting, foam, and aviation fuel. That's how come, you know, I'm originally from Alaska. That's how come so much of the groundwater and water wells in Alaska and rural Alaska were contaminated, the ones that were near the airstrips and airports. But I'm wondering, so when you're going through the testing, it seemed like that was like, you know, when we go out and test something. But so for the drinking water piece, so there's not like any, EPA has not come up with, well, now we're going to have the water operators start testing for this on their, you know, their monthly monitoring. Is there any conversations about that? Or I'm wondering about the packaging industry, because now I'm going to look at my pizza box and burger wrappers in a totally different light. And so many of our products that are on the market now, because of consumer awareness and consumer demand, you know, now I buy products that say no BHPs, no paraffins, no nitrates, and on and on. So I'm wondering, is there conversations about these things, or is this contaminant so new and emerging into the general public it hasn't been warranted yet? Thank you.
Sure. So I think to your first question about drinking water monitoring, as you can see from the map that we had up there, there has been a lot of drinking water monitoring. I think at the state level, they're moving toward, many states are moving towards more and more monitoring. I know here in Massachusetts, the legislature has put money towards essentially, you know, sampling every public water supply, and even getting into, you know, some of the larger private water supplies. So, and I think that will hold true in many states over time. With regard to packaging, you know, as I mentioned, some of the compounds have been phased out, but really replaced with other compounds. So it's still in use in a lot of packaging. I think you're probably right. You know, it's probably, this is probably the less, you know, the next, you know, what do you say? You know, you see BPA free or that sort of thing on your packaging. It would not surprise me with, you know, movies such like the documentary, The Devil We Know, and the Hollywood movie Dark Waters. With that level of public exposure, I wouldn't be surprised if you start to see PFAS-free packaging. I think if you go into the your department store and look at pans, you know, Teflon type pans, you're starting to see more and more of that type of labeling on those things. So I think packaging will be the next thing. I think I would be surprised if there's not something new for microwave popcorn, for example. I know is something that a lot of folks who kind of watch these things have become sensitive about, and I don't know if it's affected their industry, but I think sooner or later you're going to see, you know, PFAS-free microwave popcorn. You know, it wouldn't just surprise me.
Thank you. Sarah, when you say you're gonna, I know you always we have the PowerPoint, but are we actually recording the session? Because I'd like to share our PFAS presentations with the rest of the community environmental, you know, the water staff as well. This would be a very interesting presentation for the water staff.
Yeah, so we didn't record the one that we had a few weeks ago, although I did send out the presentation, but John has been recording this one. And I think that hopefully he is going to be able to provide that to us along with a PDF copy of the presentation.
Great, thank you. This is going to be very, I know the other water and wastewater technical service providers would really appreciate this presentation. Thanks.
Great. Any other questions for John while we have him?
I noticed there was some in the chat. I'm just trying to, and I apologize if I miss anybody. You can also speak up and let me know. I think I saw at least one here. The name of the documentary and the movie. So I'm going to try to get these right here. The documentary is The Devil We Know. And when you watch these things, they certainly, like any movie or documentary, they have their own, you know, bias and slant to them. And I'll just leave it at that. But and I have seen that one. And then the Hollywood movie was Dark Waters. I haven't seen that one yet, but you know, certainly I think it got a significant amount of press.
All right, great. Anything else before we thank John and let him go? All right, great. Well, thank you again, John, so much for your time in preparing the presentation and giving it to us. And then you and I will follow up via email, and you'll shoot me a copy of the presentation and the recording.
Will do.
All right, wonderful. Well, have a great week, everybody. Thank you again for your time attending, and we'll all be in touch soon.
Thank you.
Thank you.
Thank you.